Hey everybody, welcome to day one of digital learning online. This is one of the videos I'm going to be posting. I will usually try and post one of the live Zoom sessions as well, so that way you can see the interaction going on if you would like. But these videos walking through the notes will always be posted as well, and there will always be at least an answer key for your practice or whatever we're going to do that day. They'll always be posted on eClass for you. Before we start, I strongly recommend you either printing out the PDF or having it pulled up and taking notes on another sheet of paper, or on your computer you can download an extension called Kami, K-A-M-I, that allows you to write on PDFs. I would strongly suggest something to write on or a way to edit it. If you have an iPad, obviously there's easy ways to do that as well. If you have questions about different ways to write on documents, on a computer with your mouse or printing them out, let me know. We can try to troubleshoot that as we go, trying to find the best way for you to learn. So with that being said, let's get started. I'm going to try to keep these videos kind of as brief as possible, so I might talk a little fast, but feel free to pause and rewind any chance you need to. Always feel free, once again, to email me with questions as you're working through it, and I will get back to you as soon as possible. So first, kind of looking at a polynomials review from Algebra 2. Some quick definitions. A monomial is a number, a variable, or a product of a number and variables with positive whole number exponents. So your exponents have to be positive. They have to be real numbers. We're not talking fractions or anything. So you got three different things you need to look for. So it can be a number, it can be a variable, or it can be the product. So product, remember, meaning multiply. The degree of the monomial here is the sum of the exponents of the variables in a monomial. So make sure you got that word sum. Wrong button. So the sum is going to mean you're going to add them all up. So the sum of the exponents and the variables. A polynomial is a monomial or the sum of each monomial. And we'll talk about that as we go. Degree is the greatest degree of its terms. That means it's the largest degree, as we talked about, so the largest set of exponents added together. The leading coefficient is the coefficient, so the number in front of the variables when your polynomial is put in descending order. A binomial is a special case. It's a polynomial with just two terms. A trinomial is a polynomial with just three terms. So here, if we're looking at this example of a polynomial, you see it is in descending order. You got an x cubed, then an x squared, then an x, and then just your constant term with no variables. It's in descending order. So this one has a leading coefficient of 2. Its degree is 3. 3 is the largest exponent sum. So 3, then 2, then 1, then 0. It is a polynomial because there are 4 terms. Make sure we write our polynomials to the power of the terms is decreasing, so highest to lowest. So if you look at this first example, we're going to rewrite 15x minus x cubed plus 3 so that its exponents are in decreasing order, and then answer our questions. So my first term here is the negative x cubed. The negative goes with the x cubed, so it's going to stay there. My next largest x is the 15x. There is no x squared, so we're just going to leave that blank. So we got plus 15x. And then we have plus 3 at the end. So here, if I'm looking at the degree of this, if I write it in descending order, it's easy because it's my first term. So my exponent is 3, so this is a degree 3 polynomial. There's a negative in front, so that is like writing a negative 1. So my leading coefficient here is going to be negative 1. So next, we're going to look at these next examples. So remember, a polynomial, by definition, if I go back up here, is a monomial or it's the sum of monomials. So simply put, a monomial, once again, is a number, a variable, or the product of numbers and variables. So here, 9. 9 is just a number, so yes, it's a polynomial. What's its degree? It does not have any exponents, so this is a degree 0. Number of terms, how many terms do I have? I just have one term because there's just a 9. If I look at B, 2x squared plus x minus 5. Is it a polynomial? Yes, it's a number. There's positive exponents. The degree, my largest exponent is 2. And then how many terms do I have? I have 3 terms. I have 1, then I have 2, then I have 3. Next, 6 to the 4th minus x to the n power plus the square root of n. So square root of n can be written as n to the 1/2 power. 1/2 is not a whole number, so it's not a polynomial. Same thing with n. So I can't really tell the degree because I don't know what they are. I don't know what n is. But it does have 3 terms. I can at least tell that by looking at it. For d, I got n to the negative 2nd power. That's a negative exponent, so it is not a, it is not a polynomial. So if I'm coming up here, I forgot to put this, n as an exponent, or you can say exponent of 1/2 for the last term. Same thing with here. Whatever. The exponent is -2 here. So that's not gonna help. Let's look at the last one. I got 7b to the 5th, c to the 3rd, plus 4b to the 4th, c. Yes, that is a polynomial. If we look at our definitions, those are just products of numbers and variables. The degree, this term right here, I have 5 and 3. 5 plus 3 is 8, so that's got a degree of 8. 4 and 1 here, that's got a degree of 5. So this has a degree of 8 for this polynomial, and it's got 2 terms. So that's kind of how we would look at a multiplication. All right. Combining like terms, adding, subtracting polynomials. And we're looking at this. So from here, if it's addition, it's nice and easy. You're just combining like terms. What I mean by combining like terms is that you're taking the ones with the same exponents and adding their coefficients. If there's no coefficient, remember it's a 1. So those two actually have a coefficient of 1. Kind of help you out here. So if I'm looking at this first one, a, I'm going to start, my largest exponent is 3, so I'm going to start looking at those here. So I have 2x to the 3rd, and then I got a 1x to the 3rd. If I add those together, that gives me 3x to the 3rd. My x squareds, I got a -5x and a 2x. -5 plus 2 is -3. Now if I'm looking here, that's the only one with an x, so it's just going to stay a positive x. Same thing, this is the only one without a variable. So that's just going to give me my solution here. So it's just going to stay. Same thing with b. If you're going to do it on your own, you can pause it and look at it. I'm going to start with my x squared. So 3 plus 1 is 4. Then I'm going to look at my x's. X plus 4 is 5. So I have 5 total x's. -6 plus 10 is 4. And we're good to go there. Now, subtraction is a little bit different. The easiest strategy I like to do is to distribute the negative and then add them, and then you're combining like terms. If you want to rewrite the first term, you can. So what I'm going to do is I'm going to take this negative and I'm going to distribute that to everything in the second one. So what I have is 4x squared plus 5, and then negative times a negative makes that a positive 2x squared. Negative times a positive keeps that a negative. Negative times a negative, that becomes a positive 4. And now you're here, you can group, you can combine like terms. 4 plus 2 is 6. So I got 6x squared. I only have one x term, so minus 2x. And then I have a 5 plus 4. 5 plus 4 is 9, and I got my solution. So same thing, I'm going to come over here, I'm going to distribute this negative. So I got 4x squared, just going to rewrite it, minus 3x plus 5. Now when I distribute that negative, I got -3x squared. I get a positive x, and then I get a positive 8. So when we're combining like terms, our x squared, 4 minus 3 is 1, so I just got an x squared. -3 plus 1 is -2x's. And then 5 plus 8 gives me a 13, and you got your solution. All right, I'm gonna scroll over to the other page. to our multiplying polynomials. We're not talking about dividing right now, which is nice. We're just gonna stick to add, subtract, multiply, kind of a quick review from algebra. The first one we got, multiplying a monomial times a polynomial. The key here is we're just gonna use the distributive property. So we're gonna take this and we're gonna distribute it to all four. So what you got here, 2x cubed times x cubed. Remember, when you multiply, you're always going to add your exponents. So we don't multiply, it's not 3 times 3 is 9, we add them together. So 2x cubed times x cubed, 3 plus 3 gives me 6. So on and so forth, your numbers outside you multiply normally, 2 times 3 will give you the 6x to the 5th. So on and so forth. Now when you're multiplying polynomials, there's two different methods you can use. I don't care which method you use. FOIL only works for a binomial times a binomial, unless you keep distributing multiple times, which is okay, you can do that. The box method always works. Just pick one and get comfortable with it. I will show you both of them, so you can go however you would like to do it. So if I'm looking at the first one, I'm gonna go ahead and draw me my box. So I have two terms here, so I'm gonna take this y and this -5, put it right here. I'm gonna take the second one, put it going down. So I got 2y and then a 3. Now I'm gonna multiply what we got here. So 2y times y gives me a 2y squared. 2y times -5 is -10y. 3 times y is 3y. 3 times -5 is -15. Now you can take it and rewrite it like I did here, or you can just go straight from here and just combine like terms in your boxes. So the only one with the y squared is a 2y squared. I got a -10y and a 3y gives me a -7y, and then just -15, and you're good to go. So once again, you can do the same process however big of a box you want it. So if I'm looking at this one, I got an s and a 4 here. I don't really like s's, I need to change that. I got an s squared, a 6s, and a -5. The signs are gonna stay with it. So s times s squared is s to the 3rd power. S times 6x is gonna give me a 6s squared. S times -5 is going to give me a -5s. And then do the same thing with the next one. 4 times s squared is 4s squared. 6 times 4 is 24 with 1s. 4 times -5 is -20. And now you're combining like terms. So I got an s cubed. 6 plus 4 is 10s squareds. 24 minus 5 is a 19 s's, and then a -20 at the end. Now FOIL is the other method. You can distribute. So FOIL stands for first, outside, inside, last. It's very color coordinated below. I will do it with option C on our last example for you. So you can read through that and check it out. I will do option C actually both ways for you. So this one, I got a monomial times a trinomial, so I'm just gonna distribute. So x times 2x squared is gonna give me a 2x to the 3rd. X times -3x is -3x squared. And then 9 times x is 9x. Same thing here, distribute all of these. Even though it's bigger, it's okay. And the negative's gonna distribute. So I'm gonna have a 9a to the 7th to start with. That's gonna become a -5a to the 6th. And then a -24a to the 5th. And we are done there. Now the last one for FOIL, I'm gonna go ahead and take this, I'm gonna do the first. So I'm gonna multiply the first two together. So x times x is x squared, that's your first. Then I'm gonna do the outsides. X times -3 is -3x. Then I'm gonna do the inside, 2 times x is 2x. Last, we're gonna do the last term, so 2 times -3 is a -6. Combine like terms. So I got these two in the middle, so I end up getting x squared minus x minus 6 is my solution. Now if I did the box, I'd come up here, draw my box. It's a binomial and a binomial. So what I got here is, doesn't matter, I got an x, I got a 2, I got an x and a -3. Doesn't matter which one's on top, which one's on bottom. So x times x is x squared, x times 2 is 2x, Negative 3 times x is negative 3x, negative 6. And if you look at your 4 terms, this is the exact same as those. And then you're just combining as is. So I hope this is a good review for you. Kind of walking through adding and subtracting polynomials once again. If you have questions, please make sure you shoot me an email. I will be glad to get back to you. If you got questions the next day, I can start at the beginning of our Zoom, our live session, with answering those as well. But I hope this helps, and I look forward to talking to y'all soon. Hope you have a wonderful rest of your day.